Welcome to this course on mechanical behavior and testing of materials. The course code is MTPC17. I welcome you all to this course. My name is Gideon. A bit about me. I am a newly joined faculty at our institute and I'm affiliated with the Department of Metallurgical and Materials Engineering. I believe most of you, if not all of you, belong to our department. So again, welcome. I sincerely wish that we would have met in a very different circumstance, but here we are. I believe this would be our mode of communication for a while now. So let's make the best use of it, and let's see how best we can communicate with each other and understand the content of this course. Now, like this lecture, the mode of this course would rather be flipped. What I mean by that is every week, links to the lectures will be shared to you. There will be 3 lectures for each week, and the links to these lectures will be shared to you, and these lectures will actually be pre-recorded. And you can, through these links, you can watch these lectures at your own convenience. And the questions that arises during this lecture, you can share it with me through mail or via phone. I believe once we have established a team in MS Team or a group in WhatsApp, you will be able to communicate to me through that. And once I receive your questions, then we can have a separate, a dedicated lecture for deliberating the questions that you have or expanding on the thoughts that was fed into you through these lectures. Now, this mode of lecture is rather flexible. What I mean by that is one doesn't have to wait for a dedicated lecture for discussion. If from the questions I find that there are certain topics or that there are certain aspects that are very much pertinent to the subsequent lecture, then I would begin the next lecture by addressing such questions or that questions. And if there are other questions that can wait or that can be postponed to this dedicated lecture, we can discuss that in that time period. So I hope you are comfortable with this mode of lecture, and if you have any problem with this, be it the way I communicate, be it any connectivity issues, be it that you are not able to hear my sound properly, whatever it is, please feel free. Even this is new for me, and I will try to upgrade myself or try to change things around so that I'm able to reach you more clearly. Now, the reason I chose this particular mode of lecture is because I personally would have felt like comfortable being with you in person, communicating with you in person, and sharing these lectures with you in person, because in that way I would be able to like see your face, understand how the things are getting across, and if there is any problem, I will be able to like recalibrate dynamically or at the same time, and then change the way I'm teaching or what I'm teaching so that to make it more understandable. But that possibility is now not available for us, and so I thought, why not go for this mode wherein you will have the freedom of listening to these lectures at your own convenience, and rather I don't have to be bothered about the connectivities and asking every time, am I audible to you or am I visible, and all those questions that can be avoided in this mode of communication. And like I said, if you have any problem with this flipped lectures, please do let me know. I will see what best can be done about it. And quite frankly, since the odds are stacked very hugely against us, I thought, why not make the best use of it and make things comfortable for us. And that is one of the reasons I chose this mode of lectures. So having said a few words about the way I plan to conduct these lectures, let's move ahead and think about the source for this lecture. Now, for this course, I will not be following a dedicated book, but if you want, you can look into the book by Professor Dieter. The book book's name is Mechanical Metallurgy. It has been around for a while now, and students have always been recommended to look into this book to get an overview and also some in-depth understanding of certain concepts in the mechanical behavior of materials, and of course also on testing. Now, like I said, this book has been around for a while, and even when I was an undergrad, long ago, I was also recommended this book. And what I personally felt towards in certain areas, the contents of this book were rather expansive, and in certain areas they were rather introductory. So in case of the latter, you might have to look for other sources in order to get an in-depth understanding. Before going into how we would be journeying through this course, I just wanted to make one thing clear. That is, I'm not quite comfortable with the title mechanical behavior, or not the entirety of the title, but the part mechanical behavior. The reason is a wide range of behavior, or the way a material behaves, can be categorized as mechanical, or one can argue that certain way the material behaves can be categorized as mechanical behavior. One prime example is, supposing you have a rod. Let's just say you have a rod, and this rod, let's say it's made up of a plastic material, wherein the melting point is pretty low. And now you begin to heat this rod, and what you begin to see is the rod begins to lose its structural form, and the shape begins to change. So you end up having something like this. So the shape is lost now, and the original form it had, that is the form of a cylindrical rod, is lost now, and it has seemingly deformed now. And now you, instead of stopping your heat source, you continue heating it, and ultimately what happens is that this rod, because of its low melting point, it melts and it just spills around. Now, one could argue that this behavior can also be viewed as a mechanical behavior. What you ultimately see is you have a strong solid rod which loses its form, or its structural form, and ultimately, since you continue heating it, it ultimately loses its shape, structure, and everything, and physical form, and ultimately becomes a liquid. Why not call this as a mechanical response or mechanical behavior of a material? That could be an argument made for this behavior. Another example is, supposing you have a polycrystalline material. I hope you have heard this term, polycrystalline material, or if not, there is nothing much to it, like if you have two separate crystals that are joined together, a bicrystal material. Now, so let's just consider a microstructure of such a bicrystal material. This microstructure is now separated by an interface that separates one crystal from the another. Now, one crystal is categorized by an atomic orientation, which can be represented by lines like this. Yeah, so this forms one crystal, and there is another crystal whose orientation of atoms, it is being represented by the lines like this. Now you have a bicrystalline microstructure. And now when you heat such a bicrystalline setup, what happens is that the interface separating the two crystals, this interface which separates the two crystals, it begins to move in order to reduce the overall energy of the system. And now when this interface moves, the atoms which were originally aligned in this direction, they tend to realign themselves in this direction. So atoms which were originally aligned in this direction, they mechanically change their position, and they tend to align themselves in this direction. And there can also be an argument made here, why not call this as a mechanical behavior? Now, in the context of our course, we don't refer to this or the previous example of the melting of a rod as a mechanical behavior. The reason is this. Now, when one talks about the mechanical behavior in this context of the realignment of the atom, in this context of the realignment of the atom, the behavior or the mechanical aspect is confined to the material. Let me reiterate. Now, when one talks about the mechanical behavior of this here, the realignment of the atom, the mechanical behavior is confined to the material. But in our course, what we will be studying is the mechanical aspect is introduced to the material from an external source. And we will be studying the response of the material to this external mechanical condition which is imposed on the material. So what I mean by mechanical behavior, or what is usually meant by mechanical behavior in the context of this course. So when it is said that we will be studying mechanical behavior, what is actually meant in the context of this course is we will be imposing a mechanical condition to the material and we will be studying how the material responds to it. It is not how mechanically the material changes. No, we will be imposing the mechanical condition to the material and we will be understanding how the response of the material to this imposed condition is. And that is what we mean by the mechanical behavior of material, and that is what is being written here. So to give a gist about it, the mechanical behavior is nothing but how a material responds when you impose a mechanical condition to it. So the term mechanical, it is not implicitly associated with the material, but rather it is characteristic of the condition you impose on the material. I hope you understand that. And this is what differentiate the mechanical behavior that is given in these two examples, one in the melting and the other in the realignment of the atoms, from the mechanical behavior that we will be studying all through this course. All through this course, we will be imposing a mechanical condition and we will be studying the response of the material to it, not the internal mechanical behavior of the materials. Okay. Now, hopefully having clarified that, if you have any questions, again, please do let me know. I would like to clarify that before we proceed to the actual course, or before we move away from the introduction part of this course. So please do let me know. So once you understand what we are going to study or what the title actually means, then we can move ahead and see how I have formed a module for this course in order to journey through the lectures. Now, this whole course has been split into 7 modules. And before discussing what these 7 modules are, I would like to take a close look into the title of this course, again, which comprises of the term mechanical behavior, testing, and materials. So this title has 3 components to it. One is mechanical behavior, which, like I said in the previous slide, it is characterized by the conditions that we impose on the material. Like we will be imposing a mechanical condition and we will be studying a response to it. And there is a second component, which is the testing, as a part of the title, and there is also a third component, that is materials. Now once you see there are 3 components to the title, then it will be easy for me to explain what these 7 modules are. Now to begin with, the first module is, as you would expect, is the introduction, wherein I intend to introduce you to certain terminologies. These terminologies are not something that you will be using in your daily life, but once you learn them, it will make you sound more knowledgeable or someone who actually knows what he is talking about. So those terminology we will be discussing as a part of the introduction. And on top of it, I plan to introduce some historical perspective, because this research or this discussion of mechanical behavior and testing has been around for a while now, and we are a part of a very huge journey, and it is often nice to see where we are as a part of the journey. So I plan to introduce some historical perspective, so just to see where we stand and just to get a feel for the subject. And once we are acquainted with the basic terminologies and we see ourselves amongst the people who have already understood or studied the mechanical behavior, then we can move ahead and try to understand the concepts that are necessary to quantify the mechanical behavior of materials. So once you observe a material behaving in a certain manner, you need to quantify it so that it is universally understood. Such concepts will be introduced in the second module, and it will be rather elaborately discussed in the second module. These concepts will not only pertain to how the material behaves, but it will also will be associated with the conditions we introduce into the material. Now, these concepts, like I said, will help you quantify the behavior of the material, and also will help you quantify and differentiate different forms of conditions that we impose, or the mechanical conditions that we impose on the material. Since this would be the first time we will be talking about this concept, I will be taking one of the well-known testing approaches, and based on that testing approaches, I plan to introduce these concepts. And now, once we are rather fairly familiar with these concepts, and we are able to rather quantify the behavior and also the different forms of the mechanical conditions, then we can move ahead and understand how the behavior of materials actually happen, or what propels the behavior of the materials that we see in the physical world. So what I mean by that is, or what the third module entails, is that when you impose a mechanical condition to a material, there is of course some behavior or some way the material behaves, which we see through our naked eye. But this behavior is actually underpinned or propelled by something that is happening in the ground below, that is in the microscopic and the atomistic level. And in the third module, we will be talking about, or we will be looking into what actually governs the behavior we see in the macroscopic scale or through our naked eye. And that is what comprises of the third module. It will be a bit more interesting because you will get to learn several new things in this module, even though first two module might be a rather reiteration for a few of you, but in this module new concepts will be introduced. Or if you are someone who is more interested in the theoretical aspect of mechanical behavior, you would very much love this module. And once we get through all these introduction concepts and the underlying phenomena, which primarily would deal with the mechanical behavior part of it, so all these would deal with the mechanical behavior part of it, then we can go to the second part, which is the testing. We can then understand the different techniques of testing testing a material. Through the concept, we would have already introduced that there are different ways to quantify the mechanical conditions that we impose, and based on these concepts that are used to quantify, we would then devise different testings, and we understand how these materials respond to this different setups or different testing conditions. The reason one might want to see or look for different testing modes is because in real life the materials do not experience one mode of mechanical conditions, so we want to get ourselves acquainted with different loading conditions or the different mechanical conditions, and so that is the reason why we look for different testings. On those testings, as a survey would be introduced in this model. And now, like I introduced to you in the slides before, like title itself, it comprises of three components. One is the mechanical behavior, the other is testing, the third one is the materials. We cannot confine ourselves with one group of materials, meaning we cannot study the behavior, we cannot study the testing of just metals alone. We have to expand our horizon. And so in the subsequent models, we will be considering materials that are other than metals or alloys. So to begin with, we will start by considering ceramics. We will see what is fundamentally different in ceramics and how they behave under different mechanical conditions, and the reason what makes them behave in that way. And once we are fairly acquainted with that, we will move to other materials like polymers and composites. So the way we would deal with all these different materials other than metals, which I believe you would be introduced in your other introductory courses, is that we will see what makes them different from all the other materials and how these differences enable them to behave in a different way when same kind of mechanical conditions are imposed on them. And once we are able to understand their responses, then we ourselves will be able to evaluate in which conditions they would be more advantageous to us and in which conditions it is better to avoid them in order to avoid a catastrophic failure. As a metallurgical engineer or materials engineer, if we are not able to do great things, one thing that is expected of us is to avoid a catastrophic failure. So one of the reasons for including materials in this title is that we can look into these different materials and at least understand in which condition or under which conditions these materials fail miserably. And so these are the 7 modules that I have planned for this course. And like I have briefly said, what I would be capturing in each of these modules. So I hope you are able to understand it. So please let me know if you want to make any changes to this module. Since even I am also in the beginning of this course, maybe now would be the right time to make any or tweak anything in these modules. But if there are no suggestions from you, I would prefer to stick with these modules, as I believe this would in a way capture what is being given in our syllabus. Now moving on, coming to a rather a fairly important part of this introductory lecture is how I'll be evaluating your understanding. So as of now, I plan to give 4 assignments, and where I don't know, I've not decided how much to allot for each of these assignments. Maybe depending on the questions that are posed in each of these assignments, I will vary percentage for each of these assignments. And there will be a presentation or discussion that you can decide you can decide amongst yourself. It will possibly be in groups. The presentation would involve you will be presenting a topic to the class and also to me, of course, or you can have a discussion wherein it will be just your group and me, and we can have a discussion. I'll just see how well acquainted you are in what you are talking about. And finally, there is your end semester exams, and I guess in the current framework, in the current academic framework, I guess this final semester is indispensable. I guess we have to have it. So that would be the part of the assessment. So I would recommend you not to worry much about it. So this is the way I've planned to evaluate your understanding. So I hope you are able to I was able to get across what I wanted to say in this introductory lecture clearly. Please let me know if I could make any changes, be it any miscellaneous changes on my audio quality, video quality, whatnot, or if there is anything that you would like to change in the content or the way I deliver the lecture. So please let me know. Hopefully we will have some modes to communicate, and depending on the questions that I have in this lecture, I will either respond it in the immediate lecture, or maybe we can see ourselves in the lecture that is dedicated for it. So good luck, stay safe. So let's have fun learning.